Hello, engineers. Welcome to the Institute of Civil Engineers YouTube channel. In this video, we will find the bar bending schedule of two-way slab. We have already found the BBS for one-way slab. The link of video is given in description. Before starting the video, I request to please subscribe my channel for more civil engineering videos. Now let's start our topic. Before starting the bar bending schedule, let's see what is two-way slab. I simple words, a slab is said to be two-way slab if its longer span length divided by shorter span is less than 2. It is supported by all four sides and bends in two directions. The reinforcement is provided to resist bending in both directions. Now let's start the BBS part. Here the longer span is 8000 millimeters and shorter span is 6000 millimeters. The ratio is less than 2. This means it is two-way slab. The 12 millimeter main bars are provided at 150 millimeter spacing, and distribution bars of 12 millimeters are provided with the same spacing. The alternate direction crank bars are provided in both directions, that is, shorter and longer direction. The extra bars at L over 5 is also given on all sides, where L is the clear span. Now let's first find the number of main bars and distribution bars. The formula for number of bars is clear span divided by given spacing plus 1. The number of main bars is equal to 8000 millimeters divided by 150 millimeters plus 1 equals to 54.33, say 55 bars. And the number of distribution bars is equal to 6000 divided by 150 millimeters plus 1 equals to 41 bars. Now, the cut length. The formula for cut length is equal to clear span plus development length, which is 2 times 40d plus 0.42d minus 2 times 45-degree bend. For detail of this formula, you can watch the video for one-way slab. The link of the video is given in description. The cut length of main bar is equal to 6000 plus 960 plus 36.96 minus 24 equals 6972.96 millimeters. 6.972 meters. Total cut length of main bars is equal to 55 times 6.972 equals 383.46 meters. Similarly, cut length for distribution bar is equal to 8000 plus 960 plus 36.96 minus 24 equals 8972.96 millimeters or 8.972 meters. Total cut length for main bars is equal to 41 times 9.972 equals 367.89 meters. Now times for top extra bars. The 8 millimeter extra bars with 150 millimeter spacing are provided at both sides. Number of short top bars will be equal to 8000 divided by 5 divided by 150 plus 1 equals 12. Multiply it by 2 to find extra bars on both sides, and we will have 24 bars. Similarly, number of long top bar is equal to 6000 divided by 5 divided by 150 plus 1 equals 9. So we have 18 bars at both sides. The cut length for long bar is simply 8000 plus 2 times development length, that is 640 equals 8.64 meters. And total cut length is 8.64 times 18 equals 155.52 meters. Similarly, for short extra bar, 6000 plus 640 equals 6.64 meters, and total cut length will be 6.64 times 24 equals 159.36 meters. Now it's time to find the weight of the bars. The simple method is multiply the total cut length of main bar of 12 millimeter bars with 0.89 and 8 millimeter bars, that is extra bars, with 0.4, and you will have the total weight. I hope you have enjoyed the video and learned something new. If you still have doubts, do put your doubts in comments section. Please support us by subscribing the channel and stay connected for more videos of civil engineering.